Okay, so let's look at what I call the squeeze the box experiment. It's just my own nomenclature. Just for you to better appreciate how some of these things might happen. And then at this level, we're thinking of the reservoir at the level of thin section, at the microscopic level. So imagine the initial stage, the undeformed rock, the rock that was just dislodged from its parents, which you saw in those videos. It hasn't gone through a lot of changes, no compression, nothing. This is what it looks like. Imagine we, in this meeting, are different individuals. We have names. We're Osa, Biu, Kuje, Ore, Eko, and Awa. We're just individuals. We're all parts of the reservoir, okay? Just chilling. Nothing has happened to us. We're just birthed, okay? And then we imagine moving to the next stage where life begins to happen. You're transported from one location to the other, either rapidly or quietly. You saw those videos, the beach environment, you saw the alluvial environment, you saw the desert environment, you also saw the mudslide. Imagine those kind of movement. Imagine you are traveling from Enugu to Lagos, or from Kaduna to somewhere else in Abuja. Things happen, the roads, everything, you get stressed up. So that's what this reservoir is going through. It's getting squeezed because of nature, because of the realities happening, right? So right now it's thriving, there's stress. And I want you to pay attention to what has happened to the volume of space. Initially, just focus for a moment here, between Biu and Eko, between Kuje and Osa. Look at this blue, space in there. Consider that is the porosity. That is where hydrocarbon can fit in, okay? Where oil and gas can go squeeze themselves in. And then imagine that as a result of pressure, the space continues to get squeezed. And then at the last stage, you're barely surviving. Okay, you see? Because of squeezing, because of pressure, because of realities, a lot has happened. And we're seeing all kinds of reduced porosity. Okay? There's something you will see in the next set of slides, what we call pressure solutions. Where as a result of stress, we now begin to interact so closely with each other that we create something else called a pressure solution. Okay? So that's what this experiment is about. So as the reservoir goes from the initial to the altered stage, what happens? It begins to get altered. It begins to change in its property, in its porosity, in its permeability, in its capacity to really function as that original reservoir that you saw at the beach or in the desert or in the other locations. Okay, so let's think about it. Grain gets deformed because there's a lot of activities going on. There's cement precipitation around the grains. And there is what we call pressure solutions. And you will see some examples. And this is an example. Okay. So these are two different grains. And again, by the way, this is real. This is not from just an imagination. This is real rocks that was sliced into a thin section, a microscopic section. And then we looked at it in a microscope and then you observe these things. And good thing is this rock was taken from an area that was stressed. We already knew that. So we're looking out for these signatures. What you will see is this pressure solution. Because there is limited space, there is pressure, there is compression. The individual grains at those interfaces where they meet are now crystallized because of some kind of pseudo melting of the grains. It now creates what we call a pressure solution between those individual quartz grains. Okay, so that's what we call like a suture zone. Okay, and I did say, imagine tectonic plates. I talked about tectonic plates initially, right? Imagine those initial plates moving towards each other, causing the earth crust to become squeezed. Imagine what it does to the rock themselves, the rock that is being squeezed. At microscopic level, these are the kind of things that you will end up seeing. Okay, now let's go on. There's something we call, again, still looking at the reservoir in an altered state, something we call quartz overgrowths. So overgrowths are just basically chemical precipitations around the individual grains. And they are all, again, in reaction to changes in both the physical and the chemical conditions of that grains. As you continue to move, things change. Okay? So another thing I need to pay attention to will be different kinds of porosity. Here we have fracturing of the rocks. This has been stressed. And then you have iron oxide filling in this original pores. Yes.
Sorry to cut you short. We would like you to just put on your cursor. We can't see your cursor, sir.
Okay, let me see. Pointer option. Let me use a laser. Can you see it now? Can you see a laser?
Yes.
All right, great.
Thank you,
Okay,
sir.
thank you for mentioning that. All right. All right, so this is what we call quartz overgrowth. So they are basically where you have some chemical, creation around individual grains. And again, it's all as a result of changes in conditions, both physical and the chemical conditions of that rock themselves. And they're all in reaction to pressure. Now, imagine what this does to porosity. Imagine what it does to permeability, because these are like they cement, or rather they seal the connected pores. So these brownish zones were originally pore spaces, and they have become filled by iron oxide, and then eventually you now have this quartz overgrowth coming in, to further cement or block the pore spaces. So imagine what this thing does, and then imagine what fracture does to the rock. If you can see the pointer again, in this case, fracture enhances connectivity, it enhances porosity because it creates an opening. So I need to think of it as the reservoir going through all these things and changing in its porosity and permeability other than what it had from the initial stage. Okay, now I'm showing you other sections here. There are additional examples of fracture pores here. The grain, what the PQ here is polycrystalline quartz, MQ is monocrystalline quartz. It's been broken again because of stress. Just like what happens when you get tired, when you're broken, when you're injured. Okay, it gives room for a lot of other things. So that's what is happening here. And then we have clay matrix. Okay, and then I had shown you pressure solution. So think of all of this as things that can happen to the reservoir from the initial to the alter state, and how that can affect both the primary and the secondary porosity and permeability of the rocks. Okay, in this other example up here, you can see preferred alignment of the grains. They look a little more elongate in one direction. Again, that is because of compaction, compression, preferred orientation of stress in that area. And this is what it's doing to our rock. This is what it's doing to our reservoir at much tighter scale.